what we have done, we have selected all the beams in the YZ direction, and we will assign this to the same group. Assign to group all beam and add to the group. Not replace the group, we will add the content to this group. Press OK. Now we want to confirm that our group is OK. So what we need, first of all, again here we have the area, so we'll remove the area not in view, and after that select group. In the group all beams, so all the beams are selected and only columns are left. Go to view, remove selection from the view, so we have only columns left. Okay, so what we will do right now, we will select all the columns. All columns are now selected. First of all, clear the selection and select the columns. Go to XZ view and go to perspective view and select all the columns. Only columns are selected. All columns are selected. Go to assign frame section and assign column. Now view, show all, and select all the beams again. Only beams are selected. Assign frame section beams are selected. Okay, now we want to show all. Now what we will do, we will show all frame by view, show all, and in the display option we will correct the display, and I want to check how the slab and beams are connected with each other. So I don't need this window, I will close the window. Go to view, extrude view, and check how the slab and beam are connected by zoom, and we will rotate this a bit. If we see closely, the slab is connected to the middle of the beam. The connectivity between the slab and beam is from the center to center. So we need to change this. We can see this more clearly by restoring the view, and to check this more clearly, we will go to another view. Option, graphic mode, OpenGL. And extrude here. Here we have right now LAN object. Now if we see closely, we can see some portion of the slab is up, and some portion of the beam is visible. A portion of a beam is visible with this, and the slab is not connected with the bottom of the surface of the top of beam. The slab should connect, the bottom of slab or the center of the slab should be connected to the top of the beam. Okay, So we need to select all the beams, select, group all beams, and here all the beams are selected. In this view we cannot see properly, so we need to switch back to the classic view. Graphic mode, classic. Well, all beams are selected. Go to assign, frame, and insertion point. And the connectivity of slab is from the top center, which is 8. Press OK. Now what happened? The top of the slab is connected to the center of the area object. So it is now a true representation of a T-beam system, in which the top of beam is connected to the center of the slab. Okay, we need a system in which we have the top of beam to the center of the slab. So this can be done by the insertion point. This needed to be checked in the extruded view and also in the OpenGL. Now this our model is corrected from modeling point of view. We are finished. The next step is to define the loads. Define load patterns. We have dead, we need to define live load. Also we need to define earthquake load. Go to define EQX. This is the earthquake load in the X direction. The type will be the quake, and it will be auto load according to UBC 97. Add. Now this load shall be modified in modify lateral load. Here we need to define according to code different parameter. So the soil type we are taking for our example is SD. The seismic zone factor is 0.2. 0.2b. 0.2b correspond to 0.2. Also we need to define the importance factor. The importance factor we will take it as 1. Over strength factor for the concrete structure I will take it 5.5. The CT value for the concrete structure 0.03. The eccentricity ratio is taken as 5%. Press OK. Now we need to add a copy of this load. Change the name EQY. Its type is also quake. Add this load as well. Modify the lateral load. Now the soil type, again we need to SD zone 0.2, importance factor 1, over strength factor 5.5, time period factor 0.03, and this force is applied in the Y direction with eccentricity ratio of 5%. Press OK. Now here we have defined two loads. Earthquake load in the X direction, earthquake load in the Y direction, and they are auto lateral load. The load is automatically calculated from the base shear and applied on each story level in the X and the Y direction. The next step is to select all the slab. All frames are also selected, but load will be applied only on the slab. Assign area load uniform shell. In the dead load I'll add up a load of in pound feet 30 additional dead load. Remove the extruded view so that we can see the value of the load and fail object. So pound per feet 30 cape load is applied. Go back to pound feet, assign, again select all structure, assign area load and uniform shell. I have selected all structure, but the load is applied only to area. Go to live load and apply a live load of 80 pound per feet square PSF. So we have defined dead live in the gravity direction load. We have also defined the earthquake load in x and y direction. Now we need to define the earthquake load combination also for the earthquake as well. So to do this, now we need to define the load combination. Go to define load combination. In the load combination, add default design combo, and we need to define the combination for the concrete frame design. Press OK. So all the combination for the gravity and earthquake load are added. U decon 1, decon 2, these are the gravity load combination. Decon 3 to decon 10 are the combination which include the earthquake load. In decon 3 we have dead, live and earthquake. So all the combination are now added according to the 31899 and UBC 97 code. Okay. Now our model is complete from load. From modeling point of view, we are finished. We need to save again our model, and now we are ready for analysis. Press run. Model, press do not run and run now. Analysis is complete. Now we can check our displacements in the slab, in the beams as per criteria. We can check shear force, we can check bending moments, but we have done all this in the previous videos, that how a structure should be checked after analysis. We have also designed a structure. What is unique with earthquake? We have lateral load, and I am interested to see the deformation due to earthquake forces. Now let's see the deformation in the x direction. This is the deformation in the x direction, and let's check it in y direction. This is the lateral drift in the y direction. So let's check the values of the drift. In the y direction, the drift is u2 and the value is 0.18 foot, and at the bottom we have 0.17, so 0.18, 0.17, while the story height is how much? The story height with us is 12 foot. So how much will be the lateral drift? The lateral drift is 0.18 minus 0.17, 0.18 minus 0.17 divided by 12 multiplied by 100. The lateral drift is 0.08. It is less than 2%, then it is okay. And the checks after analysis, like checking the displacements, checking shear force, bending moment, and designing steps are the same as for the 3D frame. So here we are completed with the earthquake analysis using UBC 97 for a 3D frame system. Okay.